This video is an introduction to oxidation reduction reactions, and we're going to call those redox reactions because you've probably noticed in chemistry we abbreviate everything if it's too many syllables. So first I'm going to talk about where those terms oxidation and reduction came from. You've probably heard oxidation before if people talk about like rusted or reacted metal things, and that's where it comes from. People would make things out of metal, like let's say iron, and then over time as they're exposed to the air and the oxygen in the air, they would start looking like the picture. They would become oxidized. So what they figured out is what was happening is that the oxygen in the air needs 2 electrons to fill an octet. So it would take those valence electrons from metals. Metals are losers, and so they only have a few valence electrons, and they tend to give them up. So when the iron loses its electrons, it becomes a positive 2 ion. When the oxygen gains those electrons, it becomes a negative 2 ion, forming that oxidation on the surface of that metal. So the iron has been oxidized by oxygen. It came in, did its thing, took the electrons away. It had started out neutral. It had all of its own electrons, and then it lost 2 electrons to oxidation and became Fe+2. The oxygen also started out neutral. It had all of its own electrons, but it gained 2 electrons and became -2. So we say that its charge was reduced. It went from 0 down to -2. But many chemical reactions involve a transfer of electrons, and they don't have oxygen in them. We're still going to apply the terms oxidation and reduction, only instead of looking at what element it is, we're going to look at who lost electrons and who gained electrons. So if you take a look at the reaction on the screen, we have aluminum metal, which in the beginning has all of its own electrons. It's just an atom, so it's neutral. Chlorine, even though it's a diatomic element, those are covalently bonded, so they each still have their own electrons, and they are also neutral. But in the products, we have an ionic compound. We have aluminum, which becomes +3, and then chlorine, which becomes -1, and that's why there are 3 of them. So if we take a look at what happened to the aluminum loses 3 electrons in forming this compound. The chlorine, each of them gained 1 electron. So if we apply those terms, oxidation and reduction, the aluminum was oxidized because it lost electrons, but the oxidizing agent, the thing that oxidized it, was chlorine. The chlorine was reduced because it started out with a charge of 0 and that went down to -1. So what's interesting is that metals can be oxidizing agents too, even though metals are losers and tend to lose electrons. This is a reaction you've seen a couple of times in class where we take a piece of aluminum, it's an element, so it's got a charge of 0, and you put it with a solution of copper chloride. Well, in this compound, because there are 2 chlorines, this copper is +2, chlorine is -1. So in the products, we get copper metal, so it's an element, which means it has all of its electrons, charge of 0. And then we've got that same compound from the previous example. Aluminum will be +3, and the chlorines will be -1. So if we take a look at what happens to each of these in the reaction, the aluminum, again, loses 3 electrons. So it goes from 0 to +3. The copper goes from +2 to 0, meaning it gained electrons to bring its charge down to 0 from a positive number. So that means that the aluminum was oxidized by a metal. The oxidizing agent was copper. The copper was reduced. Its charge went down from +2 down to 0. Well, this reaction has a third element in it. It has chlorine. But if you look at those chlorines, they're always -1. Nothing happens to the chlorine. And when that happens, we call that a spectator ion. It's just sort of there watching, being the negative ion around all these positive things. So, in summary, an oxidation reduction reaction involves electron transfer. The thing that loses electrons is oxidized, and the thing that gains electrons is reduced. There's a couple of mnemonic devices out there. My favorite is the one that takes these 3 letters, L-E-O, and these 3 letters, G-E-R, and says Leo-Ger. And usually there's a picture that goes with it. Leo is a lion, but Leo is also Leo DiCaprio, and so I'm going to say this picture is Leo, and he says Gur, so that you can remember lose electrons oxidized, gain electrons reduced.